Howdy Pre-Cal. We are back for part 2 of 7.1 with the trigonometric identities. You may kind of feel like these are like math puzzles, if you will. They are. They just kind of make you think. Trying to manipulate, use algebra, use common denominators, use your factoring skills, use all of those things along with all the trig identities that we've learned. The Pythagorean identities, the reciprocal identities, the even odd identities. So it's a lot to remember, but the more we practice, the better we get. Just as a reminder, we're not necessarily working on both sides of the equation. Remember yesterday we said you want to start on the side that looks like it's a little bit more challenging and go from there. So as I look at example number 1, I think I'm going to start over here on the right side. So you might be wondering, how do I even start this? And if you have no clue, remember what I told y'all yesterday is you can always change things into sines and cosines and go from there. So maybe let's try that real quick and see what happens. So tangent squared x, what do we know about tangent? Tangent means sine over cosine. So if I have tangent squared x, then I'm going to change that to sine squared x over cosine squared x. So that takes care of that numerator. Now let's look at the denominator. We have secant x minus 1. Well, secant x is the reciprocal of cosine. So right now I have 1 over cosine x minus 1. I'm probably down here in the denominator going to need a common denominator. So what can I do to that 1? Well, that's easy. I'm going to turn it into cosine x over cosine x. So let's see what we have. Numerator is still sine squared x over cosine squared x. The denominator we now can write as a single fraction. So I'm going to have 1 minus cosine x over the common denominator of cosine x. So sometimes looking at the complex fraction can be confusing, so let's rewrite it where we multiply by the reciprocal. So I have sine squared x over cosine squared x, that's my numerator. I'm going to turn division into multiplication, and now I'm going to multiply by the reciprocal. So I have cosine x over 1 minus cosine x. All right, so one thing I can do a little bit of cross canceling here because I have a cosine x here. Down here means I have 2 of them, right? Remember, if it's squared, that means you have cosine x times cosine x. So I'm going to get rid of this one in the numerator, and I'm going to get rid of one of them in the denominator, which still leaves me with another one. So now as I multiply it across, I have sine squared x as my numerator, and in the denominator, I have that cosine x onto 1 minus cosine x. So we've just multiplied straight across. Let's talk about that sine squared x. And I'm going to go back to our basic first Pythagorean identity that we learned, where we had sine squared x plus cosine squared x equals 1. Based on what I want to have on the left-hand side, I really just want to have cosines, which means I need to get rid of that sine squared x. So if I were to get it by itself, over here, I now know, using that Pythagorean identity, that sine squared x is equal to 1 minus cosine squared x. And so that's what I'm going to do. I'm going to take out the sine squared x, and I'm going to replace it with 1 minus cosine squared x. Now maybe you recognize this, I hope. If you look at that numerator of 1 minus cosine squared x, that is a difference of squares. 1 is a perfect square, cosine squared x is a perfect square, and it's a difference because it has a minus sign in the middle. I'm going to move my work over here. So I'm going to factor that. That's going to turn into 1 minus cosine x onto 1 plus cosine x, all over cosine x onto 1 minus cosine x. And guess what gets to happen now? We have a common factor of 1 minus cosine x in both the numerator and the denominator. and it's going to cancel out, and we're going to be left with 1 plus cosine x over cosine x, which is exactly what we wanted to have. Now, one thing I will tell you about this particular problem, and really with any of these identity problems, is there's often more than one way to do it. So if you didn't think to do it that way, real quick, let me just go back to the beginning, and I'm not going to do this with every problem, show you multiple ways, but I do want you to be aware that there's more than one way to do it. Remember, one of the other trig identities we knew is tangent squared x plus 1 equals secant squared x. So what if from the very beginning we tried to replace the tangent squared x by what it was equal to? And according to this trig identity, it is equal to secant squared x minus 1. So what if we did that at the beginning? And we did secant squared x minus 1 as our numerator, and our denominator is secant x minus 1. That numerator is a difference of squares, so it's going to factor into secant x minus 1 onto secant x plus 1, and that's over secant x minus 1. We now have a common factor in the top and the bottom that gets to cancel out, which leaves us with secant x plus 1, which isn't exactly what we want. So let's talk about secant x. What do you know? Well, we know that it is the reciprocal function of cosine. So it's 1 over cosine x. The 1 I could rewrite as cosine x over cosine x, causing us to have a common denominator. So now I could write this as a single fraction of 1 plus cosine x over cosine x. So actually this way would have been faster, but again, it's going to come down to what are you familiar with. So that's why I'm encouraging you, go back to your notes from the first part of section 7.1 and really become familiar with these things up here, because the more familiar you are with these, the easier you can make these type of problems, because you can recognize relationships and be able to use those relationships. So just wanted to throw that out there, that there's often more than one way to do it. So when I'm looking at your work, I'm not looking to see, did you get the same answer that everybody else got? I'm looking to see, does your way work mathematically? Is everything mathematically sound? That's the important part. All right, so example 2. To me, I think that the left side looks more challenging. So let's start there. You know what? I think honestly I'm just going to change things to sines and cosines, because I already have some sines and cosines. So I'm going to keep my numerator the same. I'm going to change secant u, because I know it's the reciprocal of cosine, so I'm going to turn that into 1 over cosine u, and I'm going to keep the sine u the same. So really I only changed just the secant. Let's see. So we have cosine u in the numerator. In the denominator, this would end up being what? Sine u over cosine u, right? If I multiplied those straight across. And that's a complex fraction, so I'm going to turn this into multiplying by the reciprocal. So instead of dividing, I'm going to multiply by cosine u over sine u. And if I multiply that straight across, cosine u times cosine u is cosine squared u. My denominator is sine u. So let's see. We're starting to get somewhere. Let's think about what we know about cosine squared u. And again, if I go back to the very first Pythagorean triple, and you'll go back to this one a lot. If I want to get this by itself, I need to subtract the sine squared u over. So I would have cosine squared u equals 1 minus sine squared u. Let's replace that cosine squared u with the 1 minus sine squared u. And you know what we can do next? Let's break this up into two fractions. Right now it is a single fraction with a denominator of sine u. So I'm going to have 1 over sine u minus sine squared u over sine u. So I took that single fraction breaking it up into two fractions, what do we know about 1 over sine u? Well, that would be cosecant, right? Those are reciprocals of one another. Over here, what's going to happen if I have sine squared u in the numerator and sine u in the denominator? This means sine u times sine u. So one of them is going to cancel out from the top with the one in the bottom. So I have cosecant u minus sine u, which is exactly what we wanted to have. All right, let's take a look at number 3. So on number 3, I'm going to start on the side where I see those negatives inside of the parentheses. This is going to bring back this knowledge of your even, odd identities. So if we have cosine of negative x, that is an even function that turns into cosine of x. Bring down my minus sign. Now if I have sine of negative x, that's an odd function, so this turns into negative sine of x. Again, look back at your even, odd identities. And then what's going to happen to the minus sign and the negative sign? Well, that's easy. That's going to turn into a plus, which guess what? Is exactly what we wanted it to be. So this one was short, sweet, and to the point. We like ones like that, don't we? All right, example number 4. I definitely think I'm going to start over here on the left. More stuff, right? Well, first thing I see is that there's a negative x, so I need to go back to my even, odd identities. And so we just saw in the last example that sine of negative x turns into negative sine of x because it is an odd function. So now I think I'm probably going to do the distributive property. That seems to me to make the most sense. So cosecant x times cosecant x is cosecant squared x minus cosecant x times sine x. All right, what do you guys remember about cosecant and sine? Do you remember that they are reciprocals of one another? In other words, that cosecant is like having a 1 over sine x. What's going to happen right there to those sines? Anytime you multiply something and it's reciprocal, you're going to be left with a 1. So we have cosecant squared x minus 1 equals cotangent squared x. All right, let's go back to our Pythagorean identities, the third one that we have. And remember, we learned these back in chapter 5, but they're on your notes from yesterday. If I were to take this 1 and subtract it over, I would now have cosecant squared x minus 1 is equal to cotangent squared x. So I'm going to replace that cosecant squared x minus 1 with cotangent squared x, which is perfect because that is what's already on the other side. And so now I have verified the identity. Again, you can see it's all about knowing those Pythagorean identities and being able to manipulate them so that you can use the substitution property to put in things that you want of equal value. All right, example 5, verify the identity. Here we have sine x plus cosine x raised to the second power. To me, that seems like the logical side to start on. What does it mean if you raise something to the second power? That's easy. It means that it is being multiplied by itself twice. Which, guess what? That means we're going to FOIL. So let's do some foiling. So sine x times sine x is sine squared x. That's our first term. For outer, we're going to have sine x times cosine x. For inner, we're going to have cosine x times sine x. Now the order there doesn't matter. I'm going to go ahead and put the sine x in the front just because it was in the front for this term right here. So now I can see that those are like terms. And then for last, I'm going to have cosine x times cosine x, which is cosine squared x. All right, so let's see what we have. We have sine squared x. I'm just real quick going to move this to be right behind that, plus cosine squared x. I'm just using the commutative property there, which just says that I can change the order that I'm adding something in. And then I have these two like terms. I have a sine x cosine x and another sine x cosine x, which means I have two of them. All right, now look at what we have right here. Sine squared x plus cosine squared x. Hopefully by now you're recognizing that equals a big fat 1. So I'm going to take this whole thing out, replace it with a 1. So I have 1 plus 2 times sine x cosine x, which is good news because that is exactly what's on the right-hand side. And I have just verified the identity. So lots of algebra going on here. This is where we're really fine-tuning those algebra skills. Okay, example 6. Well, obviously the left side is more challenging than the right side because all that's on the right side is a 1. So, I don't know, maybe let's change things to sines and cosines. So I have cosine x over, secant x is going to turn into 1 over cosine x. Then I have sine x over cosecant x is going to turn into 1 over sine x. I've got a couple of complex fractions. So right at the front, I'm going to have cosine x times the reciprocal, which is cosine x over 1. I'm going to do the same thing with the second term. So sine x, I'm going to turn that into multiplying by the reciprocal. So I'm going to multiply by sine x over 1. So up here, cosine x times cosine x is cosine squared x. Over here, sine x times sine x is sine squared x. And guess what, guys? We just used this same Pythagorean identity in the last example. When those are added together, it turns into a 1, which is exactly what we have on the right side. So we are good to go. All right, example 7. So we have two things. They both look kind of interesting. I think I'm going to start over here because I see to the 4th power, and that's a little more complex than the 2nd power. So let's talk about what's going on here. Sine x plus cosine x, if I raise that to the 4th power, that means that I have 4 of them, right? I don't really want to write those out. So what if I said that that was something squared that was also something squared, right? Because that would be a power to a power. 2 times 2 is really what 4 is. Now, why would I be doing that? Well, if you remember in example 5, we actually already did a problem almost identical to it. We did the sine x plus cosine x squared. Remember what we did? We FOILed that out. So we had sine squared x, outer and inner terms were like terms, which turned into 2 sine x cosine x. Last was cosine squared x. So we have all of that, but yet we still have this outside exponent of a 2. The sine squared x and the cosine squared x, remember from the very first Pythagorean identity, that turns into a 1, still having the 2 sine x cosine x, and again we still have the outside exponent of a 2, which works out perfectly because that is the same thing we see on the right hand side. And so that one was pretty easy. If you see things that are from problems you've done previously, use that information and make your life a little bit easier. All right, we're getting closer here to the end of part 2. Let's see. Both sides look equally interesting. I think I'll start though with the right side. So if I have something squared, that means that I am multiplying it by itself 2 times. I'm going to kind of keep with the whole foiling thing because I love to foil. So let's foil together. So secant x times secant x is secant squared x. My outer term would be negative secant x tangent x. my inner term would also be negative secant x tangent x. So I have like terms. So I have negative 2 secant x tangent x. So that's my outer and my inner already combined together. And then for last, negative tangent x times negative tangent x is positive tangent squared x. All right, so we have done the foiling process. I know that I need to have nothing but signs in my final answer. So let's see what we have so far. So secant is a reciprocal of cosine. So what if I turn this into 1 over cosine squared x minus 2 times secant, again, is 1 over cosine x. Tangent is sine x over cosine x. So you might be noticing I'm just changing everything to sines and cosines. I'm just gonna see what happens. Sometimes with these problems, you just have to try something, and if it doesn't work, erase or scratch it out and restart it. So if this doesn't work out, no big deal. Tangent squared x, that's gonna turn into sine squared x over cosine squared x. Okay, so, ooh, look, guys. This denominator is cosine squared x. This denominator is also cosine squared x when I multiply those together, and this denominator is cosine squared x. So we have some good news. We have a common denominator already of cosine squared x. Let's take a look at what our numerator will be. So this numerator is a 1 minus, this is going to be 2 times 1 times sine x. So minus 2 sine x. And then back here, our numerator is sine squared x. Okay, so we have sines in the top. The problem is that we have cosines in the bottom. All right, let's talk about that. And let's actually go back to, I'm gonna rewrite our very basic Pythagorean identity. If I wanna get rid of cosine squared x, I need to get it by itself. And I would do that by subtracting the sine squared x over. So what I know is that cosine squared x is equivalent to 1 minus sine squared x. So I'm going to take that cosine squared x out of the denominator and replace it with 1 minus sine squared x. So my numerator is still what I had a moment ago. All right, let's talk about that 1 minus sine squared x, because I'm really hoping that you recognize that it is a difference of squares. So it's going to factor into 1 minus sine x onto 1 plus sine x. And while we're at it, let's talk about the numerator, because that factors. So pretend with me for a minute. Come on over here to the side of my paper. Let's pretend for a moment that I had this problem right here. That's one that we are familiar with, right? So if you were going to do a sum and product chart, your sum would be negative 2. Your product would be positive 1. What numbers are going to work? A negative 1 and a negative 1. We're going to put them over our leading coefficient of 1. Now look at the way that your variables are, because your variables are heavy in the back. So instead of having x minus 1 and x minus 1, you would have 1 minus x and 1 minus x. Do you see how that works? So our variables were heavy in the back. That's why our variables were in the back. We had no variables in the front, no variables in the front. Well, how can we apply this to trig functions? Well, instead of an x, we have a sine x. So if you use the same sum and product chart and use these same numbers, we would have 1 minus sine x onto 1 minus sine x. Does that make sense? We're replacing the x with a sine x. So hopefully you can kind of see that. Now, why is that good news? Well, look, we have a 1 minus sine x in both the numerator and the denominator, which now leaves us with 1 minus sine x over 1 plus sine x. And I love that, because that is the same thing over here on the left. So we used a lot of algebra skills in example 8. All right, so last one for today in the notes is example number 9. And I'm definitely think I'm going to start over here on the left because there's a lot going on. There's a fraction, there's something over here that's not a fraction. What do you guys remember about cotangent? Cotangent is cosine over sine. So I'm going to replace cotangent of angle A with cosine of A over sine of A. I'm not doing anything to the first fraction yet. So my mind is kind of going to the fact that I probably need a common denominator. I'm going to need a 1 minus cosine A. I'm also going to need a sine A. So real quick, let me write down the denominators for just a moment. And I don't really know why I put the sine A in the back. I normally like to have that in the front, but whatever. All right, so fraction number 1. Already had a sine A up in the numerator, but we have now multiplied the denominator by sine A, which means we are also going to multiply the numerator by sine A. Fraction number 2 already had a cosine A in the numerator, but we had to multiply the denominator by 1 minus cosine A, so we will be doing the same exact thing to the numerator. So far we're just working on getting that common denominator. So now I have a common denominator. So my first fraction, this right here, turns into sine squared A. I'm going to distribute this, but I tell you what I'm going to do. I'm going to go ahead and turn this into plus the opposite, because I'm going to distribute that as a negative cosine A. So negative cosine A times 1 is negative cosine A, and negative cosine A times negative cosine A is positive cosine squared A. So let's see what we have. I'm going to go ahead and put this numerator, just kidding, denominator right there. I went ahead and moved the sine A in the front. I just like the way that looks better. In the numerator, we have sine squared A minus cosine A plus cosine squared A. Now, as you're working through these problems, hopefully you're always looking for relationships. And I'll tell you what I see. I have a sine squared A plus cosine squared A. We've seen that a lot today. We've used it a moment ago. What's sine squared x plus cosine squared x going to equal? A 1. So this thing right here turns into a 1. Those two together turn into 1. We still have minus cosine A. Denominator is still the same, sine A onto 1 minus cosine A. And now what do you think is going to happen? We have a factor that's the same in both the numerator and the denominator, so we're going to cancel it out, which leaves us with 1 over sine A, and 1 over sine A is the reciprocal of cosecant A, which is exactly what was on the right side. All right, so as you're working through these, you're going to find sometimes that you get stumped. You might get a little bit frustrated. Don't let that bother you. Sometimes you have to erase, start over, try again. Sometimes you just need to walk away from a problem for a moment or two, or maybe try a different problem, and then come back to it with fresh eyes after you've had a break. And sometimes the light bulb above your head will come on, and you will figure out how to do it. But y'all let me know where your struggles are, what's going on with these. You guys are practicing odd problems from the back of the book, so if you're super stuck, you should be looking in the back of the book to try to help you get going. I don't want you to copy answers, but I want you to kind of figure out what it is that you have to do. You can get a little bit of help, but you need to try to be working on these as much as you can. Again, using your algebra skills and using your knowledge of all of the identities that we have been learning about since chapter 5. And I will see you guys tomorrow for part 3 of this section.